Hey guys, today we're going to be continuing on to chapter 12, section 2, and we're going to learn about some limit properties. So hopefully you printed out the blank notes. If you didn't, I would recommend doing that so you don't have to write as much. But here are the properties. You do have to know all of them, but they're very intuitive, which is nice. So for the sum property, the limit as x approaches c of f of x plus g of x, we can rewrite this as the limit as x approaches c of f of x by itself plus the limit as x approaches c of g of x. So essentially we can break them up. Please be very careful about your function notation, or not function notation, sorry, your limit notation. I noticed on your classwork assignment that some of you guys aren't quite writing it correctly. The difference property, same idea. So we can separate them apart. So the limit as x approaches c of f of x minus the limit as x approaches c of g of x. And the order matters, so be careful. Scalar multiplication property, scalar multiple property. The limit as x approaches c of k times f of x, we can rewrite this as k times the limit as x approaches c of f of x. For the product property, the limit as x approaches c of the product, we can break this apart. Limit as x approaches c of f of x times the limit as x approaches c of g of x. Be careful, you do want to keep them in limit notation. We're not doing f of x times g of x, those are different. The limit of the product can be broken up to the limit as x approaches c of f of x divided by the limit as x approaches c of g of x. Now this one has an extra little bit, and hopefully you can see where I'm going. The limit as x approaches c of g of x, because it's in the denominator, cannot equal 0, or else we run into some issues. The power property, we can rewrite this as the limit as x approaches c of f of x, all to the nth power. And the nth root property, we can rewrite as just the nth root of the limit as x approaches c of f of x. And then this also has a little tidbit because it needs to be greater than 0. So this only works if the limit as x approaches c of f of x is greater than 0 when n is even. Which, again, should be intuitive. It's just following the regular properties that you already know. And that's it. Like I said, a lot of them are intuitive. So then we're going to use the properties of limits to evaluate each limit. I didn't copy this part down, so I'm going to write it out. Our first example is going to be the limit as x approaches -1 of 2x squared minus 3 over x plus 2. So we're using the properties. So here, because we're dividing, we can rewrite this using the division property as the limit as x approaches -1 of 2x squared minus 3 over the limit as x approaches -1 of x plus 2. Now we can rewrite this using more properties. So in the numerator, we've got subtraction, so use the subtraction property or the difference property. So as x approaches -1 of 2x squared minus the limit as x approaches -1 of 3 divided by now we can use the sum, so the limit as x approaches -1 of x plus the limit as x approaches -1 of 2. Alright, and we can separate this even more because we have multiplication and an exponent, so I'm going to kind of do both of those at the same time, if you guys are okay with that. So I can rewrite this scalar multiplication, so 2 times the limit as x approaches -1 of x, and then I'm going to use the exponent property, put that squared on the outside, and then rewrite everything else. Okay. And then each one individually, when it's very broken down, is very easy to figure out without using a table or doing anything. So here, the 2 stays there, and the limit as x approaches -1 of x is just going to be -1, right? So, I mean, you can figure that out substituting it into a table, but because it's just x, it's just going to be whatever it's approaching, so -1. Here, if it's a constant like this, then it doesn't matter what x is, it's always going to be 3. So it's going to be 3. Limit as x approaches -1 of x, well, that's just going to be -1. Limit as x approaches -1 of 2, well, if it's 2 and there's no x, it's just going to be 2. And now we can solve this. So -1 squared is 1 times 2 minus 3. And then -1 plus 2 is 1. So this equals -1. So that's how we can do it algebraically. So we're just going to use all these properties and break it down. So instead of using a table to figure this out, we can use all these properties, break it apart until it's really intuitive to determine each individual limit, and simplify. That is our final answer. So if you printed out the notes, then you know that there are 2 U-tries. So I would like you guys to pause the video and try to do A and B on your own, and then when you're ready to go over it, hit play. So I'm going to just go through it. Alright, so this one doesn't have any division, it just has adding, subtracting, and some exponents and scalar multiplication. So start off by breaking this apart. So limit as x approaches 3 of x squared plus the limit as x approaches 3 of 2x minus the limit as x approaches 3 of 7. This can be separated more because of exponents. I'm going to put it in parentheses. Don't forget your equal sign. This one we can separate because of scalar multiplication. And this one just stays as is. And I mean, you could kind of jump to the next line for that 7, like you know it's just going to be 7. I like to do it all in one step. I think it's easier. So this is just going to be 3 squared. This is going to be 2 times 3 because it's approaching x. And minus 7. And then that's pretty easy, right? 9 plus 2 times 3, which is 6, minus 7, 8. So hopefully you got 8 for your final answer. Alright, last problem. Again, pause if you haven't done it yet. Now we have a radical, so I'm going to use the root property. So we're going to have the square root of, and then I'm going to do 2 things at once and separate the adding. So we have the limit as x approaches 2 of x plus the limit as x approaches 2 of 4. So then the radical stays there. This is going to become 2 because the limit as x approaches 2 of x will just be whatever it's approaching. And then this is going to be 4 because that's constant. 4 plus 2, 6. And can we simplify the square root of 6? No. And we are done. So that's it. Yeah, you can combine steps like we did here, but I need to clearly be able to see your separation. So I would not want you to jump to that second line. You need to at least separate everything so it's in limit form. Be careful of your limits, be careful of your tables, be careful of everything. Please look at your classwork so that you can get that feedback from last week and make sure you're doing all right. And that's it.